What do housing, parks, roads, wildlife, water, jobs, and shopping all have in common? They are all individual features of our natural and man-made landscapes. Understanding the nature of these places and their connections are important to residents, policymakers, businesses, and agencies. Geographic Information Systems, or GIS, combines technology, data, and people to help answer these questions related to our natural and man-made world.
Today, GIS is being implemented in hundreds of thousands of organizations, and it's helping them make better decisions and run operations and make organizations better, actually. But at the same time, it's becoming a new language, a kind of new medium. Maps are becoming pervasive across organizations, explaining how things are in the organization, giving insight, understanding relationships, patterns, processes, helping us understand the future.
Shasta College has a Geographic Information Systems program that is considered a career technical information program. The college's program requires students to work on a GIS project.
My name is Emily Sachs, and this is my first semester taking GIS courses at Shasta College, and I chose to map Reading art in public places. I've chosen mostly outdoor things so that people could potentially go on this tour and not have to worry about businesses being open, and they can just kind of do it when they feel like it. This is the online version of my map. It's in ArcGIS Explorer online, and I've imported the layers that I made for ArcMap into ArcGIS Explorer online, and anyone can view it. So if you were looking at the legend and you knew that you wanted to go see something in Turtle Bay, you would just go to the green dots for Turtle Bay, and when you hover over it, their item number, their title, and the artist pop up, and then you can just click on the one that you want to get more additional information. I definitely think that it's a really valuable tool, and it makes me happy to see that we're using it more often to make better decisions.
It's really dynamic, and it's like endless possibilities, from mapping the London Olympics to the Panama Canal, the widening of the Panama Canal.
I think what is special about GIS is that it is so useful in so many different applications, so many different fields. It seems to be most commonly used in the natural resources areas, in the forestry, things like that. So we were given the project of mapping the trees here on campus, and we had some of our clients were the physical plant, which is the maintenance crew on campus. We also had the master gardeners. We're very interested in using the project for tree identification purposes. The plant ID class itself, same thing, plant identification purposes.
Originally, the project started with an ortho image, and the points were digitized manually. Wherever there was a tree canopy, a point was set. So that was the original tree map back a few years ago. When we took over the project, what we did was we went and took the study area and went out and actively ID'd them using a handheld GPS and walked each tree, which gave us the precise location.
But I know most of, at least my focus on the project, what I thought was our main goal as far as usefulness was for physical plant. They often have trouble with the oaks, especially in the grassy areas of campus, because they get too much water, and a lot of them will actually rot out in the center, and you don't necessarily realize it until all of a sudden branches are falling off and causing major damage.
Trying to symbolize all these different species of trees was impossible in one layer. So I divided them up into 6 different layers, where in the GIS, you can look at just the native trees, or you can look at just the ornamental trees, or you can look at the native deciduous independently of all the other points.
Courses are designed to train students in the 3 basic elements of GIS.
So there are 3 essential functions that GIS serves. One is data collection and management, a second is analysis, and a third is display. And so data collection and management involves gathering data from existing sources, collecting new data through GPS and other methods, and also the maintenance of the data and accessing the data through geographic databases. A second area is the analysis side, and through analysis we are able to combine geographic data and we're able to extract information from our geographic data to answer what-if scenarios. So we can look at things like what would be the impacts or the benefits if we were to build a new road, or if we were going to add a park, or we were going to build some industrial facility. And it can also be more simple than that as well. It can be things as simple as somebody that wants to pull up their parcel of land and find out what sort of adjacent land ownership or land uses there are in relation to where their property is. The third is display, and display at its basic level is usually maps. We all have seen maps. They've been around for thousands of years, but nowadays we have tremendous range of tools to be able to do the graphical side of producing maps. But we also have the ability now with computers and mobile devices to be able to have interactive maps that have changeable scale to them. The content of the scale changes as one moves in. We have the ability with mobile devices and GPS to be able to place ourselves on the maps.
Shasta College's GIS curriculum provides technical education that aligns to the competency model developed by the U.S. Department of Labor. GIS courses are transferable to university programs, and the students gain experience working with professionals on projects that benefit the community.
I think the best advice that I could give is that if people are really interested in doing the GIS certificate program, completely invest yourself in it. Do all the classes together, because I feel like following the program as it's laid out, you'll be able to learn the most and retain the most of the information.
Vestra started in 1988, and we started primarily as a GIS-centric firm offering GIS consulting services. So we had 4 interns that were working on the Shasta Community Wellbeing Atlas project, which is funded by one of the organizations in Shasta County, but looking at how you can use GIS for community well-being. And so some of the interns were gathering data, finding information and assembling it. And then all the way to some of them taking the data that was gathered and making maps, or just sort of running analysis on that information.
I came into Vestra they had some extra technician level work, and so I worked mostly with one of the GIS analysts that they had here, and mostly on data capture, capturing zoning, general plan for certain future land use planning projects. That was my main thing I did as an intern.
It's pretty impressive, the program that Shasta College has, and the quality of the students that we see coming out of there. So for a relatively small community like Reading, compared to some of the bigger cities, I think they've done a wonderful job of sort of having a GIS footprint in the North State, and doing some things that are very cutting edge, and great opportunities for students and the community to benefit from that learning environment.
GIS is used in a wide variety of applications, including community planning, hazard mitigation, and business development. Collaboration between Shasta College and local private and public sectors helps the students by building skills through real-world experience. This combination of student projects that provide data and services in support of regional initiatives and a curriculum based on national standards is the key to success in preparing students who want to go on to a 4-year program or start in the workplace. The college also encourages young children and teenagers to learn technical skills by providing local schools with activities and a curriculum for grades K through 12. In the years ahead, GIS and other geospatial technologies will play an increasingly prominent role in our economy and daily lives by making order out of our complex world.